Alright, so now let's look at really two examples, and I'll write them all down first here. I want to look at 0, 1, 0, 1 minus 0, 0, 1, 1. So I want to do that, and then I want to do 1, 0, 0, 1 minus 1, 0, 1, 0. And hopefully you should be able to look at these and say, the top number is bigger than the smaller number. The top number is smaller than the bottom number. So we're going to kind of have two cases here, and we'll see what happens. So for our first case, let's do that guy. So we're going to have 0, 1, 0, 1 as our x, or our leftmost. So we're going to have 0, 1, 0, 1, and we're going to be subtracting 0, 0, 1, 1. All right. Now, well, also this input here, we're going to assume that we're not borrowing anything from this place. There's no column to the right of it, so we're not borrowing anything. So we're going to have, say, a borrow of 0. Let's see what we end up with here. So we've got a 1 minus a 1. So we don't need to borrow to do that. We know that our difference is 0, and since we're not borrowing, we can just say 0 there. Now, we've got a 0 minus a 1. We can't do that, so that means we have to borrow. So we're going to put a little borrow input there. Well, so it's an output for this adder, but it's an input for this one. And so now, since we're assuming that we're borrowing, we have a 1, 0 minus a 1. And so that means that we end up with a 1 there. And now we've got a 1 minus a 0 minus a 0. Or, sorry, 1 minus a 0 minus a 1 is what this borrow means. So that ends us up with a 0. We don't need to borrow, so you can put a 0 there. And now we've got a 0 minus a 0 minus a 0, and that output is a 0. And we've got that. So it turns out when we're detecting underflow, or if our difference has gone negative, the big thing that we need to look at is this borrow right here, right? This is our important bit. If we're borrowing from this spot, that means that our difference went negative. It means that we're trying to borrow from something that's not there. And notice that when I did this borrow here, I didn't even bother to see if there was something to borrow from here. I just said, hey, I'm doing it. I'm going to do it. So it's just kind of the way these things work. We don't have all this communication to say, hey, do you have something I can borrow from 2 bits up? It doesn't really work that way. It kind of all just works and takes what it needs, is the way our circuits are designed. So now let's look at our next case here, our next example, where we're subtracting a number that is bigger than our top number here. So we've got a 1, 0, 0, 1, subtracting a 1, 0, 1, 0, and of course we're going to say that we're not borrowing anything, or having anything borrowed from us, more properly said here. So let's go to our nice purple. So we've got 1 minus 0 minus 0, which we can do that, and that comes out to be a 1. And so we don't need to borrow, so we can just set our borrow to 0. And now we've got a 0 minus a 1. So we've got a 0 minus a 1, so we're going to have to borrow. And now this changes this problem to a 2 minus a 1. So we have a difference of 1. Now we've got a 0 minus 0 minus 1. So we're going to have to borrow. And that leaves us with 2 minus 1, and 2 minus 1 is a 1. Now we've got 1 minus 1 minus 1. So we do have to borrow, and so that gives us 3 minus 1 minus 1, because remember this borrow increases this value to increases it by 2 units, so we have 3 minus 1 minus 1, so that gives us a 1 here, and that's it, right? We've got all of our inputs and outputs determined. So what do we do here? Well, we've got, really just looking at our sum, we've got 1 1 1 1, and so what are these values here? Well, we've got 9 minus 10. And what do we end up with? We ended up with 15. If I know that this is an important thing here, but kind of what this looks like is we've got a 15. But really it should be negative 1, right? Negative 1 is what we should have there, but we don't. And part of the big thing here is that we can't actually display negative numbers in our unsigned binary. That's what unsigned means. We can't have a sign there. We just always assume it's positive. And as it turns out, this bit right here indicates an underflow. It indicates that a number is going negative. So for subtractors, let's go with this deep blue again. I like that deep blue. For subtractors, if our what do we want to say? This is our borrow I. It's our borrow out is what it really is. This is a borrow in. This is our borrow out. If borrow out equals 0, we have no overflow. Or sorry, not overflow, underflow. Sorry. And if B out equals 1, then we do have an underflow. That means our sum went negative. And that means we can't represent it with our number system.